In this video, I will talk about counting rules. In many cases, there are a large number of possible outcomes. Counting rules can be used in these cases to help compute probabilities. Counting rules are the rules for counting the number of possible outcomes. Counting rule number 1. If any one of k different, mutually exclusive, and collectively exhaustive events can occur on each of n trials, the number of possible outcomes is equal to k to the nth power. So if you roll a die 3 times, then there are 6 to the third power outcomes, which is 216. So if you think about it, a die has 6 sides, so you have 6 outcomes on one die. If you do it 3 times, that's 6 times 6 times 6, or 6 to the third power. Counting rule number 2. If there are K1 events on the first trial and K2 events on the second trial, and so on all the way down to Kn events on the nth trial, the number of possible outcomes is K1 times K2 times K all the way to the nth. So you want to go to a park, eat at a restaurant, and see a movie. There are 3 parks, 4 restaurants, and 6 movie choices. How many different possible combinations are there? Well, you know you have 3 parks. You times that by 4 restaurants, and you times that by 6 movie choices. So if you multiply them all together, you have 72 different possibilities. 72 ways you can pick. You can go to Rubio's Park and eat at McDonald's and go see Jumpin' Jack Flash. Or you can go to Rubio's Park and eat at Burger King and go see Jumpin' Jack Flash. So you have different combinations that you can make out of those 3 parks, 4 restaurants, and 6 movies. Counting rule number 3 is the number of ways that n items can be arranged in order. So this is n factorial, which is equal to n times times n minus 1 all the way down to 1. So you have 5 books to put on a bookshelf. How many different ways can these books be placed on the shelf? Well, that's 5 factorial. 5 times 4 times 3 times 2 times 1. So that's 120 different possibilities. Now, some of you may not have a calculator that does factorial. Actually, your cell phone, if you turn your calculator a certain way, you'll get more button options. It might have a factorial on there. You can do factorials in StatCrunch, so I will show you how to do that. So if you go to StatCrunch, we are going to go to Data, Compute, Expression, and then we're going to go on to Build. We're going to scroll down till we see Fact. Okay, so I double click it and it pops up in this box. And in this box, well, not box, well, it's in the box, but you have a set of parentheses. You want to type 5 within those parentheses. So now you have fact 5. And you hit OK, hit compute, and it shows up here. Fact 5, factorial 5 is 120. So some of these you can do by hand, like 5 factorial, you can do 5 times 4 times 3 times 2 times 1. You can do that by hand, but if you have larger numbers, then you want to use a calculator. I also did a template where you can put it in. This is a permutation and combination template that I'll show you in a few, but for factorial I have a little cell that says n factorial, and in the column next to it that's colored you can type in 5, you hit enter, and oops, I'm sorry, it didn't show up. Okay, should show up here. So I'll type it in here for you so you guys can see. There we go. Alright, so let me clear it out. I'll clear it out. And now I'll type in 5. So if I type in 5, oh, for some reason it's not working. It should show up here. Okay, hold on. I'll change it to 7. There we go. I have to put the right cell in there. So type in, I'll clear it out again and I'll show you again. Okay, I'm going to type in 5, hit enter, and as you can see in factorial, it says equal is equal to 120. So you can use my template if you want. Like I said, anytime an answer comes up, you're free to click on the cell to see what the command is. And the command for factorials is equal fact. All right. It's not. Okay. So let's talk about permutations. The permutation is ways of arranging X objects selected from N objects in order. An example of a permutation is if you have a lock. You know, they call it combination lock, but it's actually not a combination lock. It's permutation lock, but no one's going to say permutation lock. But anyway, um, in order for you to unlock the lock, you have to have the numbers, the key to it. The numbers have to be in a specific order. So if my code is 36, 19, 20, I can't enter 19 and then 20 and then 36 because it won't unlock. It has to be in a specific order. So a permutation is where order matters. So the command for permutation, or the formula, is n factorial all over n minus x factorial. So an example is you have 5 books and are going to put 3 on the bookshelf. How many different ways can the books be ordered on the bookshelf? So in this case, order matters. So you can do this by hand. This is the key to it. It says P with the N in front and the X after. So N is the total number of objects and X is how many out of those 5 are you dealing with, or out of the N you're dealing with. So uh, we're dealing with 5 books, and you want to look at 3 of them, on how to arrange 3 of them. So this would be 5, 3. And so you can plug everything back into the equation, but once again, you're dealing with factorials. And as you can see, you get 60 different possibilities. But there's actually Excel commands and StatCrunch commands that will do this for you. So when we go to StatCrunch, once again, we're going to go to Data, Compute, Expression, Build. And the command that we want to look for is perm. This is it right here. So I'm going to hit double click it, and as you can see, you get this. It pops up in the box with parentheses. You also have a comma, and that's because you have to type in the 2 numbers. So in our case, we're going to type in 5. That's the total number of objects, and the ones that we want to arrange in order would be the 3 books. So you got to make sure you're after this this comma, and you put in 3. So it'll look like this: perm 5, 3. Okay, we're going to hit OK, and then we're going to hit compute. And as you can see, I get an answer of 60. It shows up in the second column. I also have an Excel template for it, same template that we use, and we're going to use the n equals and the x equals. So we want 5 in the first one and 3 in the second one. And it should pop up. I don't know what's going on with my computer, but whatever the case, I'll put it in there for you. It will be 5, 3. Alright, so as you can see, you get 60. So the command in Excel is PERMUT 5, 3. But with this Excel sheet, I'll have it where you just have to type in the n, the x, or whatever your n factorial is. But for some reason, it seems like it deleted it out. But that would be the answers. Okay. We also have a combination rule, and combination order does not matter. So that's the number of ways of selecting X objects from N objects. Order does not matter. So for example, you have 5 books and you are going to select 3 to read. How many different combinations are there, ignoring the order in which they are selected? So once again, this is going to be, this time we have C. We have a total of 5. We're looking to pick out 3. Okay, so as you can tell, the formula is a little different. It's n factorial divided by x factorial times n minus x factorial. You can put everything into your all the numbers into the formula and calculate it, and as you can see, you get 10 possibilities. Okay, so let's go ahead and do this in a StatCrunch. We're going to go to data, compute, expression, build, and this time we're going to look for combinations. So COMB, comb. Double click it, and then you can put in your numbers. We're going to put in a 5, and make sure it's in parentheses. 5, and then 3. Oops. Sometimes you got to move it over. 3. There we go. I'm going to click OK and hit compute, and we get an answer of 10. To do it in my Excel spreadsheet, I already have the 5 and the 3 here for n and x. The command for combination is COMBIN, and then we're going to put in the cells in which the values are located. And as you can see, I get 10. Once again, you can click on the Excel file on the answer, and it'll tell you what command I used. Okay.